An automatic ammunition factory is a manufacturing plant that uses advanced technology and automation to produce ammunition for military, law enforcement, and civilian use. The factory is designed to produce ammunition efficiently and quickly, with minimal human intervention, resulting in increased output and reduced labor costs. The production process in an automatic ammunition factory typically involves several steps, including material preparation, powder loading, bullet casting, priming, and packaging. Each of these steps is typically automated, with machines and robots performing the tasks with high precision and speed. The material preparation stage involves feeding raw materials, such as brass, copper, and lead into the factory. The materials are then melted down and shaped into casings, bullets, and other components needed for the ammunition. In the powder loading stage, gunpowder is measured and loaded into the casings, followed by the insertion of the bullet into the casing. The priming stage involves adding a primer to the base of the casing, which is essential for igniting the gunpowder and firing the bullet. The final stage of the production process involves packaging the ammunition into boxes or crates for distribution. This stage also involves quality control checks to ensure that the ammunition meets the required specifications and standards. Automatic ammunition factories have several advantages over traditional ammunition production methods. They can produce large quantities of ammunition quickly, efficiently, and with high precision, resulting in consistent quality and reliability. They also reduce the risk of human error and injury, as most of the production process is automated. However, automatic ammunition factories also pose some risks, particularly in terms of job losses for workers who previously performed manual labor in traditional ammunition factories. There are also concerns over the potential for increased weapon proliferation and the risk of accidents or malfunctions due to the mass production of ammunition. The AK-47 is a widely recognized assault rifle that was first developed in the Soviet Union by Mikhail Kalashnikov in the late 1940s. It was officially adopted by the Soviet military in 1949 and went on to become one of the most widely used firearms in the world. The AK-47 was released through a combination of factors, including Kalashnikov's expertise as a weapons designer and the needs of the Soviet military at the time. Kalashnikov was a veteran of World War II and had extensive experience with firearms. He began designing the AK-47 in 1945, shortly after the war ended, and completed the first prototype in 1947. The AK-47 was released for service with the Soviet military in 1949, after extensive testing and refinement. The rifle was designed to be reliable, easy to use, and durable, and it quickly gained a reputation for its ruggedness and reliability. The rifle was also relatively inexpensive to produce, which made it an attractive choice for countries with limited resources. Over time, the AK-47 became a symbol of resistance and revolution around the world. It was widely used in conflicts in Vietnam, Afghanistan, and the Middle East, among other places, and it remains a popular weapon among insurgent groups and paramilitary organizations to this day. The AK-47 is a selective-fire, gas-operated assault rifle that was designed in the Soviet Union by Mikhail Kalashnikov. It is one of the most widely used rifles in the world, due to its reliability, ease of use, and low cost of production. The process of assembling an AK-47 rifle involves several parts that need to be put together. The main components of the rifle are the receiver, barrel, bolt carrier group, trigger assembly, and the stock. The receiver is the main body of the rifle and is made of steel. The barrel is inserted into the receiver, and the bolt carrier group is attached to the receiver. The trigger assembly is then added to the receiver, and the stock is attached to the back of the receiver. Assembling an AK-47 rifle requires a good understanding of the firearm's design and functionality, as well as knowledge of the proper tools and techniques needed to assemble the parts correctly. It is important to note that the assembly of firearms should only be done by trained professionals or individuals who have received proper training and possess the necessary skills and knowledge. The AK-47 is a selective fire, gas-operated assault rifle that was designed in the Soviet Union by Mikhail Kalashnikov. It is one of the most widely used firearms in the world, known for its reliability, durability, and ease of use. The AK-47 operates on the principle of gas operation. When a round is fired, some of the gases produced by the burning gunpowder are diverted from the barrel through a small port in the barrel and into a gas cylinder located above the barrel. The gases in the cylinder push a piston, which in turn moves a bolt carrier rearward. The bolt carrier is connected to the bolt, which unlocks from the barrel and moves rearward, extracting and ejecting the spent cartridge case, and cocking the hammer. A new round is then stripped from the magazine and chambered as the bolt carrier moves forward, and the gun is ready to fire again. The AK-47 has a rotating bolt with two locking lugs that engage recesses in the barrel. This design helps ensure the rifle's reliability in adverse conditions, as the loose tolerances between the bolt and barrel allow the gun to function even if it becomes dirty or fouled with debris. Overall, the AK-47's simple, robust design and gas operation make it a highly effective and reliable weapon, and it remains in widespread use around the world. Steel production. The first step in making an AK-47 is the production of high-quality steel. The steel used in an AK-47 is typically made from a combination of iron, carbon, and other metals. Forging. Once the steel is produced, it is forged into the rough shape of the AK-47's various components, such as the receiver, barrel, and bolt carrier. Machining. The rough components are then put through a series of machining processes, where they are precisely cut and shaped into their final form. Assembly. Once the components are finished, they are assembled into a complete AK-47. This typically involves fitting the components together, testing the firearm for functionality, and making any necessary adjustments. Finishing. The AK-47 is then finished with a coating to protect it from corrosion and wear. This can include bluing, parkerizing, or other types of coating. It's important to note that the production process of an AK-47 can vary depending on the manufacturer and the country in which it is produced. Additionally, the manufacturing process for AK-47s may involve the use of specialized machinery and tools, as well as skilled labor. The modern ammunition manufacturing process involves the use of top-class technology to ensure the production of high-quality ammunition that meets the needs of the military, law enforcement agencies, and civilian shooters. The manufacturing process consists of several steps, including designing, testing, and manufacturing the ammunition. Designing the ammunition. The first step in the ammunition manufacturing process is designing the ammunition. The designers use computer-aided design (CAD) software to create the design of the ammunition. The software allows the designers to create a three-dimensional model of the ammunition, which can be tested for its performance in a virtual environment. Once the ammunition design is complete, the ammunition is tested to ensure its quality and performance. The ammunition is tested for its accuracy, velocity, and reliability using a range of testing equipment such as chronographs and ballistic gelatin. The components of the ammunition, such as the bullet, casing, primer, and powder, are produced separately. The components are made using different manufacturing processes such as casting, stamping, and forging. During the manufacturing process, quality control checks are performed at every stage to ensure the ammunition meets the required specifications. The quality control checks include visual inspection, weight measurement, and dimension measurement. Once the ammunition is manufactured, it is packaged and shipped to the customers. The packaging is designed to ensure the safe transportation of the ammunition. Overall, the modern ammunition manufacturing process is a highly advanced process that utilizes top-class technology to ensure the production of high-quality ammunition. The process involves several steps, including designing, testing, and manufacturing the ammunition, and uses advanced technologies such as CAD software, automated machines, quality control equipment, robotics, and data analytics.